Hello everyone. So let's now solve practice assignment week 11 question number 4. Suppose z equal to fx plus y times g of x for some polynomial function f and g. Which of the following options are true? So we have to check the second order partial derivative for function z. So if we find first partial derivative of the function z with respect to y, then now here fx is a function of x. So when finding the partial derivative with respect to y, it would be 0. And for here, this term, y times g of x, it would be just g of x. Now, if we take the second order partial derivative with respect to y again, here g of x would be some function of x, so there would not be y term involved, so here y would be 0. So, first option is the correct answer. So, let's now solve practice assignment week 11 question number 5. Define a function like this. Choose the set of correct options. So, options are asking us to check for the second order partial derivative, and mainly the mixed partial derivative, that is fxy and fyx. So to calculate these, we need to calculate the partial derivative with respect to x and y. So first calculate partial derivative with respect to x. Now for a function like these, where it is a piecewise function, so its partial derivative would also be defined as piecewise. That is when xy is equal to 0 and when xy is not equal to 0. So when xy is not equal to 0, we can directly use our quotient rule and find the partial derivative of this term with respect to x. So first, let's simplify our function as x cube y minus xy cube divided by x square plus y square. Now with this function, if we apply the quotient rule here, that is u by v form, so we will get u derivative v minus v derivative u divided by v square. So it would be 3x square y minus y cube into x square plus y square minus 2x into x cube y minus xy cube divided by x square plus y square whole square. So this is when x comma y is not equal to 0 comma 0. Now when xy is equal to 0, as because it is a piecewise function, so we will go with our limit theorem, that is limit h tends to 0 form. So fx at 0 comma 0 is defined as limit h tends to 0. So it would turns out now the function value at the point 0 comma 0 is 0. So it would become okay. So now here y value is 0, x value is h, and if we put that in above function, that is x cube y minus xy cube divided by x square plus y square. As y is 0 for these both term, because of this y here becomes 0, so the whole numerator would become 0. So we will get f of h comma 0 to be 0, and 0 by h will give us 0. So the limit this will turn out to be 0. So the partial derivative with respect to x for the given function f at the point 0 comma 0 is 0. So this is the partial derivative with respect to x. Now same way we will find the partial derivative with respect to y also. It would also be in piecewise form. So let's apply the quotient rule again, this time with respect to y. So it would be x cube minus 3xy square multiply with x square plus y square minus 2y into x cube y minus xy cube divided by x square plus y square whole square when xy is not equal to 0, 0. And again, for checking the partial derivative with respect to y at the point 0, 0, we will use limit theorem, and it would become now again if we look at the function form where x value is 0, y value is h. So again the numerator would become 0. So the function value at the point 0, h would be 0. So this limit would be equal to 0. So partial derivative with respect to y of the function at the point 0, 0 is also 0. Now notice both the partial derivative with respect to y at the point 0, 0 is 0. So the last option is correct. Now remaining three options are about the second order mixed partial derivative fxy and fyx. So now first let's consider the partial derivative with respect to x. If we want to find the fxy, then we have to take the partial derivative of the function now with respect to y, and we have to calculate it at the point 0, 0. So now again, as the function is a piecewise function, so we will use our limit theorem to find the partial derivative of the function with respect to y. So fxy at the point 0, 0 would define as limit h tends to 0 fx at 0, 0 plus minus because again the partial derivative with respect to x at the point 0, 0 is 0, so we will left with this one. So we have to see the function value at the point 0, h. So here at the point 0, h. So x value is 0, y value is h. So because x value is 0, so this term here would be 0. So it would vanish. We will left with this term here. And in this also, this would become 0 because x is 0. And this would also 0. So we left with minus y cube plus y square. That is minus y power 5. And y is about h. And in the denominator also, this would be 0. This is y square, so it would become h square and the whole square, so h power 4. So we will get minus h power 5 divided by h power 4 and this h. So this would become minus h5 divided by h5, that is negative 1. And what is given in the option is also the same. fxy at the point 0, 0 is negative 1. Similarly, we will find fyx. Fy h comma 0 by h, because fy at the point 0, 0 is 0. Now here what we want to find is at the point h comma 0. So y value is 0, x value is h. So as y value is 0, so again this term would be vanished. So y value is 0, so this would become 0 and this would become 0. So you're left with x cube into x square. So that would become, as x value is h, so it would become h power 5 and divided by h power 4. That is same as this. So the derivative comes out to be 1. And that's what given in the option. So these are the correct answer. Thank you.